In this question, we'll be looking at the gravity field on the planet Pluto. It reads, the acceleration of free fall on Pluto is 0.66 meters per second squared. Says an object weighs 6.0 newtons on Earth. What would this object weigh on Pluto? Okay. So I would suggest beginning with the end in mind for a lot of questions on paper one. It's very likely that you will be taking a paper one type of final exam next week. So you can guess, if you sort of, get stuck on something, you at least get the benefit of sort of, guessing, but you also need to show all your work for questions that require your work. And so it will cost you marks if you get it right with a guess, it's not going to be worth as much as if you get it correct with correct working. So you get marks for the working as well. So keep that in mind. You'll be expected to show all your working. And so even if you're used to calculating, and sort of doing your calculations in the calculator, you'll need to be mindful to spend some time writing down your calculations, off to the side in any of the free space sort of there. So it doesn't have to be very formal. It should just sort of be clear to somebody else that is sort of looking over your work, sort of what you did there. So weight is equal to mass times the acceleration due to gravity. You should have this sort of equation in mind for weight. It comes from the more general Newton's second law, force equals mass times acceleration, and the force due to gravity we call weight, and so the acceleration due to gravity we call local g. So weight equals mass times g. That's sort of where that comes from. So we need to kind of use this equation to solve for the weight on Pluto. We're given this, so you kind of think about this as local g. It's local to whatever sort of gravity field we happen to be in. On Earth, g is 9.81, but on Pluto, it's only 0.66. So that's kind of nice. They give us g. Our job is to use the same equation with the information given for Earth to deduce mass. Mass is an intrinsic property of a substance. Mass is inertia. And remember what Bill Nye said, inertia is a property of matter. So let's use this weight equation here on Earth, where we know there is 9.81 newtons per kilogram, or 9.81 meters per second squared of acceleration of free fall here on Earth. If the object weighs 6 newtons on Earth, and on Earth, let me put this. Let me slide this over just a bit here. I'll just work right here. If the object weighs 6 newtons on Earth, right, that's the force, that's the weight, then we're solving for the mass by dividing each side by g, right? So we divide by the 9.81. Again, newtons per kilogram. You just kind of move that back up to the numerator. Let your newtons cancel. Mass in kilograms, 6 over 9.81. 6 divided by 9.81. We can solve that the mass of this object is 0.6116 kilograms, because remember, Newton is a kilogram meter per second squared. Now this object possesses this mass no matter where it is in the universe, right? It's intrinsic to it. It's basically the amount of atoms that makes it up, and that's not going to change depending on where you are in the universe. But the influence of gravity on that mass, right, changes your weight from place to place in the universe. And so on Pluto, an object that weighs 6 newtons on Earth would weigh, plug back in the consistent 0.6116 kilograms for mass, the given gravity field strength for Pluto, and you get a 0.4 newtons. So choice A is correct. If you got 4.0, which I think many of you did, it could be like an order of 10 error. I don't know if anybody tried to convert, kilograms to grams or something. So try to give yourself feedback about if you didn't arrive at choice A, well, why didn't I get choice A? It could be because you didn't attempt the calculation. You thought, no, I'll be fine. I'll just guess on the final exam. That's not a recipe for success. Okay, so you want to sort of reflect on your learning habits there. It's okay to attempt something and get it wrong and learn from the mistake. In fact, that's a great way to learn. What's a shame is when students, feel like, well, I don't, know how to do this. I won't even attempt it. That's what we call a fixed mindset. And you want to have a growth mindset where you you don't mind making mistakes. You don't mind failure. You're bound to fail. That's how we learn. So don't be afraid to, sort of try something. Physics is tough, when you're first learning it, but it's a way to make sense of the universe. And that's kind of powerful. So, choice A for question 8.